Welcome back to Module 3 Memory System in the session 6 subject Computer Science or Computer Organization. Myself Dr. Shabintar. Here let us start with the today's table of contents. We'll discuss in detail the mapping functions like direct mapping, associative mapping and set associative mapping. What is mapping? Mapping function determines how memory blocks are placed into the cache. What is a necessity to place the memory block into the cache? Yes, processor whenever it reads a block, if it is not found in the cache, then it is a miss. Then there is a requirement that whichever block is not found in the cache, it has to be brought from the memory to the cache. Now, in this regard, now it will decide which block has to be replaced, which cache block has to be replaced. This is decided by the mapping function and with the help of a replacement algorithm. A simpler processor example is, let us take a cache consisting of 128 blocks, of each block 16 words. The total size of cache is 128 into 16, that is 2048, 2k words, which is nothing but 2k means 1k is 2 power 10, 1024 multiplied by 2, you will get 2048. Main memory is addressable by a 16-bit address. Main memory has 64k words. Main memory has 4k blocks of 16 words each. With this example, let us discuss the all three types of mapping: direct, associative and associative mapping in detail for the above example. Let us take the direct mapping. The cache has 128 blocks starting from block 0 to block 128. Now, here block is 128. Now, uh, you can see in the direct mapping, the memory address represented by three fields: word, block and tagged. So, in the each block of cache is of how many words? Each block 120 block of 16 words each. So each block contains 16 words. So 16 can be represented by 2 power 4. Hence 4 bit is needed. 4 bit is there in the main memory address, which represents a lower order 4 bits represents a word in the cache. Okay, next block 2 power 7. 2 power 7 is 128. So that represents a which block it will house the word. So that next 7-bit field is represented by the block of the cache. Next tag field, the rest remaining 5-bit because the address is 16-bit, 7 plus 4 is 11, 16 minus 11 is 5. Next 5-bit is used as a tag field. Now let us see how the mapping takes place from main memory block will be mapped to the cache. Block J of main memory maps to the block J modulo 128 because there are 128. This is the equation J modulo 128 of the cache. Let us take any of these. 1 modulo 128, you will get 1 only. So block 0 will map to block 0 of the cache. Block 1 of the main memory will map to block 1. Block 127 will map to block 127. Now let us take J. 128 block of main memory. 128 modulo 128 will be 0. Modulo function which evaluates gives the result of remainder. So remainder 128 divided by 128, the remainder is 0. So whatever, so 128 block will be mapped to the block 0. That means here the cache will can store more than one block onto the same position in the cache. Next 129 modulo 128, you will get remainder 1. That means 129 block will be mapped to the block 1 and so on. Let us take 256. 256 modulo 128. It will 256 uh, 256 when it is divided by 128, you will get 2. That means it will be mapped to the block 2 of the cache. So let us see. Now let us summarize this. More than one memory block is mapped onto the same position in the cache. As we see, block 0 will house block 0 of the main memory, block 128 of the memory, and 256 of the main memory. Here, uh, this may lead to contention. Contention means there are more number of competitors for the block 0. If the block 0 at the same time block 0 is also requesting, block 256 also requesting, then the problem arises. Then there is, this is called as contention. Uh, this may lead to contention for the cache block even if the cache is not full. That means block 256 and block 0 can be placed only in the block 0 as per the direct mapping. Even though the other blocks are free, the cache blocks are free, it cannot place, it cannot be mapped. So in order to resolve the contention by allowing the new block to replace the old block can be replaced with a new block. It will lead to trivial, which is complex replacement algorithm. Memory address is divided into 3 fields. As I told you, low order 4 bits determine one of the 16 words in a block. When a new block is brought into the cache, then the next 7 bits determine which cache block is the new block is placed. High order 5 bits determine which of the possible 32 blocks, because 2 blocks are used for each block, no? So 128 divided by 2 is, so it can, I mean it so it is no, one, not 128. So it is high order 5 bits, which is represented by 2 per 5 is 32. So 32 blocks is currently present in the cache. These are tag bits. Simple to the direct mapping is very simple to implement but not very flexible. Let us see the next example or next mapping technique, associative mapping. Here, the main memory block can be placed anywhere in the cache memory block. The limitation which was found in the direct mapping is eliminated here. Memory address is divided into 2 fields, word field and tag field. Word field because each block contains 16 words. Say that's why it is represented by 2 per 4, 2 per 4, which is 16. So 4 bit is used as a word field. Low order 4 bits identify the word within the block. High order 12 bits identify the tag bits. It identifies a memory block when it is resident in the cache. It is, what is the advantage of associative mapping? It adds flexibility and uses cache space efficiently. Whichever is there, it will use the block of the cache. Cost is higher than the direct mapping because the need to search all 128 patterns to determine whether a given block is in the cache or no. The searching time is incurred here. Set associative mapping. Here the blocks of cache are grouped into sets. Mapping function allows a block of main memory to reside in any block of a specific set. So divide the cache into 64 sets with 2 blocks per set. So one set contains 2 blocks. So here 128 divided by 2 is 64. Now memory block 0, 64, then 128, etc. are mapped to the block 0 and they can occupy either of the 2 position because it contains a set, block 0 or block 1. The 6-bit field determines the set number. and the high order sorry, I'm sorry, here it should be would have been said, not I mean, okay. So 6-bit field determines the set number. High order 6-bit fields are compared to the tag field of the two blocks in the set. So set associative mapping is a combination of direct and associative mapping. Then, but here the possibilities here are in the direct mapping. Uh, More than one block is containing only for the one block of the cache, but in this case you have two in one set, the contention is reduced. That means the drawbacks of the direct mapping and associative mapping is dealt or in the set associative mapping. Number of blocks per set is design parameter. One extreme is to have all the blocks in one set requiring no set bits. Then it is called fully associative mapping. Other extreme is to have one block per set. It is same as direct mapping. This is a range fully associative to direct mapping. Thank you. These are the references. End of the session 6.